So now we will discuss that particular method, which we call as Euler's phi function. Okay, so this phi function we represent it as phi n. Okay, this is also called Euler's totient function as well. It plays a very important role in cryptography, especially in asymmetric cryptography. So this function will find the number of integers that are both smaller than n and relatively prime to n. So here as well, in this method also, we were finding all the primes which were less than n, but the method was very time consuming. So here as well, we are finding all the integers that are smaller than the given number and they are relatively prime to n. Right, so both the things are being done in this. But how do we use it? How do we calculate the value of this phi function? So we have a number of steps, or we can call them rules. We have a number of rules for it. So based on the number we have, based on the value of this n we have, or this n I must say, we use the corresponding rules, right? Okay. This totient function or this phi function, we find out the arithmetic modulo n for this, right? And for arithmetic modulo n, we have a complete set of residues, which is 0 to n minus 1. So these things you might be remembering these things because we have already discussed all these remainders, residues, set of residues, all these things in previous classes. Now the reduced set of residues is those numbers which are relatively prime to n. One thing we have is complete set of residue, another thing we have is reduced set of residue. सो कंप्लीट सेट में तो सारे के सारे नंबर्स आ जाएंगे जो भी रिमाइंडर हो सकता है एक अरिथमेटिक मॉड्यूलो n के लिए. And in reduced set of residues, we have only those numbers which are relatively prime to the given number, right? जिसके लिए हम ये मॉड्यूलो n फाइंड आउट कर रहे हैं. For example, I'll tell you the example और अच्छे से क्लियर हो जाएगा. For example, if we have n equal to 10, then the complete set of residues will be this one, okay, which is 0 to n minus 1, which is written over here. 0 to n minus 1 it is. But the reduced set of residue will contain only those numbers which are relatively prime to n. Now what is this relatively prime? When you find the GCD of the two numbers, then the GCD will have to be 1, right? So the reduced set of residue for arithmetic modulo 10, it will be 1, 3, 7 and 9. Okay. So out of these 10 values, now we have only 4 values in the reduced set of residues. So these numbers are relatively prime to 10, right? They have the GCD as 1. So if you find GCD of 1 and 10, value will be 1. If you find GCD of 3 and 10, value will be 1. 7 and 10 and 9 and 10, the GCD will be 1. So the number of elements in reduced set of residue is called the Euler totient function. So we can, we are finding the number of elements in the set, right? कि कितने numbers हैं जो given number से smaller हैं और relatively prime है. So that is our task which was listed over here. Okay, smaller than n and relatively prime to n, right? So we will be using this function. Okay, so this function phi n, it will calculate the number of elements in this set, right? जो भी smaller है और relatively prime है to the given number. So the following rules will help us to find the value of phi n. So first rule says the the value of this function phi 1 will be 0 because this number is 1, right? So its value will be 0. तो अगर सिर्फ 1 के लिए अगर हम लोग फाइंड आउट करते हैं 1 itself is not a prime number, तो हमारे पास जो number of numbers होंगे सेट के अंदर that will be 0. Now second rule says phi p if p is a prime, तो हमारे पास कितने एलिमेंट्स होंगे सेट में? दैट विल बी p minus 1, right? This might sound confusing right now. I'll show you the example. तो उस टाइम पे और अच्छे से क्लियर हो जाएगा. Right, so second rule says that this phi p, where p is a prime, it will give you p minus 1. Next is phi m into n. If we can represent this p as m into n, then how we can find out the number of the prime numbers which are smaller and relatively prime. We can write it as phi m into phi n. Okay, and this m and n, they should be such that they are relatively prime, right? So this thing we have to keep in our mind. So further, this thing can be solved using this expression. We can write it as m minus 1, we can write it as n minus 1, because m and n, they are relatively prime. Fine. Fourth rule says if you have this prime number having some power, जो हमने factorization के time पे भी देखा, we can factorize any prime number in form of the power as well. So if we have any number in the form of power, we can write it as, if the given number is p raised to e, we can write it as p raised to e minus p raised to e minus 1, right? So here this condition should be satisfied that p is a prime. Okay, so these are the rules which we follow to find out the number of primes which are smaller, and the given number which are relatively prime as well. So these two things we are finding out. So we can combine the four rules to find the value of phi n if it is needed. So if n can be factored as this thing, जैसे हमने एक previous example भी I've shown you the example of 3600 जिसमें हमारे पास multiple factors थे and those factors were having powers. तो अगर हमारे पास ऐसा expression है, so in that case we can combine the third and the fourth rule. So third और fourth rule जो है, it says this thing, right? तो यहाँ पे ये भी factor अगर power वाला है और ये factor भी अगर power वाला है, तो यहाँ पे हम इन चीजों से इसको रिप्लेस कर सकते हैं, then we can multiply it. So we can write this third and fourth rule combinedly just like this one, right? So this is one factor, this is another factor, this is the last factor, right? So here this rule is a combination of third and the fourth rule. So the difficulty of finding phi n depends on the difficulty of finding the factorization of n. So that thing we have already discussed, that this is a difficult thing to find out the factors of the given number, right? And if we have found the factors of given number, we can easily find the value of phi n. Now I'll show you some examples so the things will be clear to you. Okay, so the first example, it is finding out the value of this 3513. So 513, which rule will be applied? The second rule. First वाले में तो 1 value थी तो 0 ही आएगा, right? So यहाँ पे second rule was कि 5p है हमारे पास और जो p है that is the prime number. So here this 13 is prime number. So the value we were having was p minus 1. I'll show you. Here you can see. What does this second rule says? It gives you the result as p minus 1. So we can see that 13 is the prime number, right? And the result will be 13 minus 1. So there are 12 numbers which are smaller than 13 and are relatively prime to 13, right? So we can check as well. 1 से लेके 12 तक सारे के सारे numbers जो हैं, they are smaller than 13 and they are relatively prime, right? With 13, right? Okay, next example is the value of phi 10. Now 10 is not a prime, right? Prime number नहीं है, so हम ये वाला second वाला rule apply इस पे नहीं कर सकते हैं. So we will go with the third rule अगर हम लोग apply कर सकें तो इसको. So we will now represent 10 as the multiples जो कि prime होंगे. So we can represent 10 as 5 into 2, right? और 2 और 5 जो हैं they are prime numbers and they are relatively prime as well. So the third rule is getting satisfied. So we can write it as phi 2 and phi 5, right? इसको हम आगे फिर कैसे डील करेंगे? This phi 2 इस पे फिर second rule apply होगा. This will be 2 minus 1. Okay, it will be 1. This will be, इस पे फिर वापस से second rule apply होगा. This will be 5 minus 1 into 4. So जो result है हमारे पास क्या आ जाएगा? That will be 4, right? So here these 2 and 5 they have to be relatively prime and primes as well, right? So as an answer we have 4. So up to 4 we have up to 10 we have 4 numbers which are prime and relatively prime to 10 as well, right? Then we have next example which will show you the combination of the third and fourth rule. So 240 can be written as this factorization, okay, prime factorization this is. So we can write it as 2 raised to 4 minus वहां पे भी क्या था p raised to e minus p raised to e minus 1, right? तो यहाँ पे e की वैल्यू 4 है, so यहाँ पे e minus 1 यानी कि 3 हो जाएगी, 4 minus 1. So this will be this will be yes 16 minus 8, तो 8 हो जाएगी इसकी वैल्यू. This will be 3 minus 1 2 and this is 5 minus 1 4. So as a result we get 64. Okay, so there are 64 numbers which are smaller than 240 which are prime and they are relatively prime as well, okay, with 240. Fine. Next example we have, okay, this is somewhat confusing. So we have this phi 49. We can represent it as phi 7 into phi 7, okay? So this will give you 36 because this is prime, this is prime. But the 7 and 7 they are not relatively prime, right? Relatively prime कब होंगे? जब इनकी GCD की वैल्यू 1 आएगी. But 7 and 7 का GCD जब आप फाइंड करोगे तो इनकी GCD की वैल्यू 1 नहीं आएगी, इनकी GCD की वैल्यू 7 आएगी, right? So this rule does not apply over here. Okay, so we will go with the another rule, right? So we will be representing it as the power of primes. Okay, we can write this 49 as 7 raised to 2 and then the fourth rule applies over here. So 7 raised to 2 minus 7 raised to 1 will give you 42, right? So this is how we use these rules to find out the number of primes which are smaller and relatively prime. Okay, so it says what is the number of elements in Z14? So this is the set of residues, okay, reduced set of residue. So 14 ko we can represent as 7 into 2. So 7 this is prime, this is again prime, they are relatively prime as well. So 7 minus 1 6 हो जाएगा, 2 minus 1 1 हो जाएगा and this will give you 6. So it shows that the number of elements in this set are 6 and these members are 14 तक जितने भी number prime numbers जो होंगे those will be the members of this set. So those numbers are 1, 3, 5, 9, 11 and 13. So these numbers have to be relatively prime as well with 14, right? So इसीलिए हमने इसके अंदर 2 को इंक्लूड नहीं किया है बिकॉज 2 and 14 they are not relatively prime, right? So interesting point here is if n is greater than 2, then the value of phi n is always even, right? So that is something interesting जो हमने previous examples किए हैं उसमें भी आप लोग check कर सकते हो। जैसे ही n की value 2 हो जाएगी तो जो इसकी value है वो हमेशा even ही आएगी, right? So that's all about the Euler phi function, right? इसके आगे हम लोग एक और थ्योरम करेंगे which is called Chinese remainder theorem which will help us to understand this asymmetric key cryptography in a better way.